Okay, thanks Bruno. Okay, so today I'll be talking about Syzix. So I don't know who caught it, but yesterday I gave a brief talk on this subject in the sysadmin mini-conf, which was basically just a very brief 10-minute overview of the project. So today, I don't know who did not. Yeah, so I'm going to start with basically the same set of slides, but not quite so crazy or chaotic, and then just go from there with some more details about the project. Unlike yesterday, if you have questions, feel free to interrupt and stop me. They may be answered by later slides, but that's okay because we can either wait or deal with it as the case happens. So I really liked Bdale's keynote yesterday because for two reasons. First of all, this is a personal itch of mine that I have been slowly scratching for years now, 3 or 4 years, gradually getting things to a state where they are very nearly usable for me personally on my personal machines. And also because of what he was saying about lowering the barriers to contributions from users, that all users could be developers, and that if that was the case, then free software would be in a better position. So I'll come back to that a bit later on. Okay. So for a traditional package install on a normal, traditional sort of distribution, the files for each package end up being splattered basically all over the file system. You'll get programs to run in /bin, libraries in /lib, same for the /user versions of those, and there are rules on visibility and stuff like that for this sort of thing. Syzix doesn't do this at all. So in a traditional package management system, you tend to have a single version of any given package that can be on the system at any point in time, just by virtue of the fact that you've got files going into these common locations. If you want to have more than one version, you'll probably end up with clashes in /bin, /lib, and so on. So you can only have one version of a package. Syzix doesn't do this. What Syzix does do is install each package into its own location in the file system. And by default, the path looks like this. So it starts with /sw. Everything is under /sw, stands for software. And then underneath that there's a repo or repository, which is basically just a sort of fairly arbitrary package grouping sort of thing, followed by an architecture, something like x86, 64 Linux. So it's sort of like the triples, but without the sys part, just the CPU architecture and the kernel. And then comes the name of the package as another directory, and then finally a directory for each version. So what this allows you to do is have multiple versions of any package on the system sitting there concurrently, which I think is a very good thing. And it's also done by some other systems, some of which have been around for a while. So GNU is probably the oldest one, which I suspect quite a number of people are familiar with. But there are others in various forms. So in Python land, there's virtualenv, which is a system for managing multiple Python version installs and their Python modules. RVM, so in Ruby, there's a similar thing, Ruby Version Manager. Well, similar but different. There's a newer one called OSTree, which is, again, similar but different. It's more about managing entire trees of operating system installs. And it's mostly used by the GNU folks, by the GNOME folks. There's a distribution called Gobo Linux, which I suspect quite a number of people have heard about. And it also supports this notion of multiple packages installed. And then finally there's NixOS.
Perl.
Sorry?
Perl.
Right, so I don't know about Perl, but there's one for Perl as well. To be honest, the domain-specific ones don't interest me terribly. And so out of curiosity, in this audience, who's heard of NixOS here? Oh, you're kidding, less than yesterday? Okay, anyway, we'll come back to that. So what all of these systems tend to rely fairly heavily on is symlinks. Lots and lots and lots of symlinks. And Syzix does not do this, or does not like this, and certainly not as a primary sort of mechanism. What Syzix does do, though, is use the environment. In particular, path and various other search paths. So LD library path for libraries, C path for header files, stuff like that. What this lets you do is not only have multiple versions of any package installed concurrently, but it lets you dynamically choose which one you want at runtime. And you can do that on a per user basis or per process basis. Yes?
Just ask you, about the path, isn't there a limit to the size of the path?
Yes.
All sorts of problems?
Yes, and we can come back to that. Or these days it's a quarter of stack size, which is, or you can make it bigger still, but we can come back to that later on. Yeah, that's an advanced thing. So I think being able to dynamically change the version of a package that you're using at runtime is a really good thing. And so now, oh sorry. And so the way that Syzix does this, it's built on primarily on top of a piece of software called environment modules. Has anyone in the audience heard of this? No. So environment modules have been around for a long time, over 20 years, and they are a system for managing your environment in this sort of way, but they primarily seem to be used in HPC and supercomputing settings and haven't really got much traction elsewhere. We'll come back to this though. So this is an example of how you go about using Syz, which is the main utility in Syzix. So you can ask it which packages are loaded currently in your environment. So at the moment there's 4. These are sort of the base ones that you have to have for the system to even function. Things get a bit meta because you can see there's a Syz one there, and that's the one that provides the Syz utility itself. But so you can see environment modules is specifically version 3.2.6. The others are, the version is devel, which basically means that they're a Git clone, and that just makes life developing easier. So suppose I wanted to use Python. Well, it's not available at the moment, so that's fine. I can ask the system what Python packages are available. It tells me there's 267, 273, some wrapper version for 273, and also a version for Python 3 if I'm interested. So I can go ahead and load one of those, Python 267 for example, and now I've got access to that version of Python. If I ask what Syz files I've got loaded now, you can see that the original 4 are still there, and at the end, number 14, there's the version of Python that I asked for, but it's also dragged in all of the runtime dependencies, and although some of those might be build time dependencies, anyway. And they're also loaded in the environment. And what I can do now is, suppose I say, okay, I actually think I need Python 2.7, so I can just do a Syz swap with that version of Python, and that's the one I've got now. And I can just, if I don't want Python anymore, I can unload it, and it's gone. And this is all just fiddling with the $path and $Python path and all that sort of thing, and we'll come back to more of this a bit later on. So this gives some interesting properties with such a system. The first is that the notion of is the system stable or unstable doesn't seem to make a lot of sense to me in this context anymore. That the system's kind of both stable and unstable. That if you wanted to, you could run a system with a collection of known, good, stable packages, package versions, and those are the ones that you run all the time, they're the default. And then if you want to test out a new version, or if you want to run unstable packages, then you can have them installed at the same time as well. And you don't need to make this value judgment of, do I want a production stable system or do I want a bleeding edge development system? The distinction's sort of meaningless. So you can, if you want to look at some unstable packages, for example, then you can either just install them and make them the default, and then if things go pear-shaped, that's okay, you can just roll them back, which basically means changing the default back to what it was, assuming you haven't uninstalled the previous version off disk yet. Or you can go the other way if you're more conservative, and you might just leave the defaults alone and install the new version of the software, and then switch to that version and load it just in a single login session and test things out before making it the default. So you can test new versions before actually, installing them. So the intention of Syzix is sort of primarily more aimed at a rolling release kind of system where new versions of all sorts of packages on the system come along all the time, much like other rolling release distros like Arch Linux and stuff. But by the same token, it still supports the idea of sort of standard releases, where you have basically these boil down to just a list of packages and package versions which are known to work well together. And you can call that, a version of Syzix. It supports the idea of binary packages. So since everything lives in /sw, and with a toolchain in there, based out of there, then everything's self-contained in /sw, and you can tar up even just simple tarballs. I tend to use Slackware most of the time, so tarballs are nice and simple, and I like that. Along the same lines as Gobo Linux, because everything's separated out in the file system, that the mantra of the file system is the package manager sort of applies here as well, which makes tarballs nice and simple. But at the same time, supporting source builds is also a nice thing. And like Gobo Linux, because the file system is the package manager, you can hand install stuff, packages, and they're first-class citizens, and they get treated the same as any other package on the system. Syzix has a build tool, and one of the main features of that is that builds are parameterized by version, or rather not parameterized. So everything's sort of cookie cutter, and the rationale behind this is that for most software, most of the time, the actual build process doesn't change from release to release. And so you should be able to take advantage of that and even have end users saying, I want the latest version which was released 1 day ago of such and such package, and just be able to do it, assuming there's no build system changes, build process changes, which is most of the time. So in theory, it supports the idea of a standalone install where Syzix is your distro that's installed, and that's what's used for everything at boot time. I'm not there yet with that, but NixOS has such a mode and it's very similar, so I'm sure that it's possible. But at the moment, mostly what happens is that installs tend to be hosted. So you've got your existing distro that you use, and it can be whatever, anything, EL-based, SUSE, whatever. But because everything lives in /sw, you can just unpack everything in there. You need sort of a one-time initialization to read stuff out of there, and after that you're done. So sort of in the first case, Syzix looks a little more like a distribution. In the second case, it looks a little more like a package collection, and it's kind of a bit of a hybrid of both, really, I think. The target audience is so large multi-user systems, and in fact that's where pretty much all of this has grown out of. That at NCI, where I work, we run Australia's peak academic supercomputers, and so we have shared login systems where we can have hundreds of users logged in simultaneously, and they all want slightly different versions of the packages that are on there and the compilers and so on. So we need a system for managing that, which started out with ad hoc sourcing of shell-specific RC files, and grew up to modules, and is in the process of growing up beyond that still to Syzix or a system substantially like it. But also power users and developers, I think, would benefit from this notion of being able to switch around packages very quickly and easily. So this is where the talk yesterday ended. So I'll go ahead now and just go through some of, just a little bit more detail on some of the basic ways that the system's arranged. If you've got any questions, feel free to stop me. And then if I get through all of this basic stuff, then I'm happy to sort of follow where people are most interested in looking at. What's going on? Okay. So returning to the previous example of a relatively clean environment, if we want Python, then we can load it. And this time if we ask again after loading Python, what's available that matches Python, you can see that we've got, can I point? Actually, I'll just... So you can see we've got the original set of Python packages, and they're the actual Python ones, but we've also got this section here, and these are the Python modules that are provided by this particular version of Python. So you can see that these actually live in the file system underneath that Python install, there's a directory called SW, and the structure under there is basically the same as under the root/SW tree. So we can then say, okay, well I might want Python Boto, and so I can load that up. And now if I look at the list of sys files that I've got loaded, then you can see that we've got, this is from here up is what we used to have, and there's Python Boto, and this is what it's pulled in as its dependencies. And now, so now if we try to use it, then it works, and that's to be expected. So you can see the reason that it's working is because when we've loaded the Python Boto module, it's added this path to Python path, which is where to find it. And again, you can see that lives underneath this particular version of Python. If we decide, okay, now I want Python 2.7 instead of Python 2.6, I can swap that out. And in this case, you can see that now the list of packages is again basically the same, except that we've swapped out for Python 2.7 and it's pulled in these two extra dependencies. The Perl is only because OpenSSL has Perl scripts in it. So now if we try to use the Boto module, it still works. And if we look at Python path, we can see that in fact the Python Boto directory that's there is the one that now lives underneath Python 2.7 installation. And that's important because if we still had the previous one from the Python 2.6 installation, that may have a different ABI, and that module would almost certainly not work in Python 2.7. So the way this works is when you unload the Python module, you've still got these three other packages which are loaded, and they're sort of these sub-packages of Python 2.7. And what happens is they then go inactive. So this is an indication that you would like to have those packages loaded in your environment, except there's nowhere to get them from. The only place that they were has been unloaded. And now what happens is when you come along and do a sys load of a different version of Python, the system notices you've got these inactive packages that you would like to pick up, and suddenly now there is a location for those. It's in a different place than it was before, but that's okay. So they get automatically loaded then. Okay. So the way that all these dependencies and what each package provides in terms of your environment is specified in terms of these things called sys files. This is what they look like, and you can ask sys to show you. The -r in this case means raw, which means the file as it is on disk, and I'll show the distinction against not raw in a second. And so basically the idea is that they're just a simple abstract description of the things that are provided by that package. So the stuff that's in the file system rooted at that point in the tree, and also other information about the software such as the requirements that it has. So the bin says that there's a directory that contains binaries, and it's called bin. And the system then interprets that as meaning that it needs to mess with $path. And there's a location for man pages. There are Python include files, so Python modules inside lib Python 2.7 site packages. This Syzix SW is currently not implemented, but how did it get separated? What actually is implemented is the modules dir one. Again, that's because Syzix is built on top of modules, and that just tells the system where to find these sub-sys files for the actual Python modules for this particular version of Python. And you can see that all of these, and so on for libraries, the include dir is for the actual Python devel headers. And the soft prereqs are all the dependencies. The first layer of dependencies. And these will get resolved further as necessary. The soft prereq basically says that if the user has, so for example for glibc, if the user has any version of glibc loaded, then the requirement is satisfied. and if they've got none, then the system will automatically load glibc 213. And so this needs to be slightly more expressive down the track so that I can say, you know, this package needs glibc 211 or higher, that sort of thing, but that should be fine down the track. And all of these paths on disk are all relative to where the package is installed. So what that means is if we look at the sys file for Python 267, it's basically the same. The only differences are that we're looking in libpython 2.6 instead of 2.7. And to be honest, I wish Python would automatically figure that out for itself because it knows what version it is. And there are different prerequisites because this version of Python doesn't need OpenSSL. So the actual, if you do a sys show of Python, this is the modules, a module file as opposed to a sys file. Sys files are automatically translated into module files, and this is what the environment module software uses. In this case, it's now no longer a descriptive language, it's more interpretive. So prepend path blah says stick this at the front of $path, and so on. See that paths are not relative, and there are things like policy things such as, for example, when you specify a directory full of libraries, do you want that to set library path, LD library path, or LD run path, or some combination of the above? And in different scenarios, you may want different situations. And so that's why it's better to have a descriptive system which says, here are libraries, and then on a site-wide basis, or a per installation basis, you can then decide policies such as what that actually means for users in terms of the environment that they get for accessing those libraries. And there's some other stuff at the end which is fairly uninteresting. There's a simple script that will go through and generate a sys file given a software install. It does the sort of straightforward, simple thing that you would expect, looking at what's in there and just simple heuristics to guess what it should be. And this is very often a good approximation, first approximation at least, of what the software provides. So for the case of Bash, it provides binaries, it needs glibc, that's pretty much it. In terms of the actual sys program, it's not so much a program. You might be wondering how it can influence the environment of the actual running process itself. And the answer is that it's not really a program, it's actually a shell function. It does, however, use the output of a program, which is this underlying sys command program. And that's what actually interprets the sys files, uses modules, and then outputs the commands necessary to adjust your environment to be in the right state. And then there's this syzup, which is a sort of initialization script, and that's where the sys function is initially defined, and where the paths to find the initial set of sys files is set, and so on. It's in the root because there are possibly other places you could put it, but I find that to be the easiest. And so typically you would have this sourcing of this file in your login.bash login or .bash profile or similar. It's actually just a symlink into the default version of the sys package. Okay, so are there any questions on this stuff so far? Okay, so next I'm going on to comparisons with other systems, the systems I mentioned before. Should I go for your questions first, I think? Yeah, shoot.
When you do a sys swap, like what you're doing earlier with Python, is that atomic, or is there a period of time in which you actually don't have Python in your path?
It's atomic. You can think of it as just an unload followed by a load. The difference is that if there are requirements, they're still satisfied, right? So if you have a requirement saying some other package needs Python and insists on that, there's a way of specifying that. If you try to do a sys unload, it'll fail. But if you swap it out for a different version, that'll still work. But it's atomic in the sense that your environment changes once at the end as a collection of changes to the environment, and that's that's the end of the story then. Does that make sense?
Yep, thank you. Was there another?
There was one up the back.
Yeah, I was just a bit confused as to why the Python modules were under Python, the Python path and then /SW,
Yep.
rather than site packages. I was a bit confused there.
Repeat the question.
Yeah. So the question. We'll jump back.
Yes.
Where are we? Yeah. Okay. So in this case, so the question is. I should have brought a mouse. So the question is why are the Python packages living underneath this /SW instead of directly under lib Python blah site packages?
Yep.
So the answer is you might want to have several different versions of each Python module. So suppose you want Python Boto 2.6 and 2.5 and 2.4, suppose. If you stuck everything under the site packages for this particular version of Python, then you're back to the same old situation where you can just have only have one version, you can't choose, and when you load that version of this 267 of Python, you get all those modules and there's no way to not have them or to change the version.
So in other words, I could have Python 2.7.3, but also have something like matplotlib version 1, matplotlib 1.1.
Yes. So the comment then was that you could have Python 267 and then inside that you have matplotlib 1.1, 1.2 and so on, and the answer is yes. The answer is then so that begs the question that yes, if you do want a full complement, you need this full matrix of all your Python modules built against all your Python versions. But to me, that's a scripting exercise. That's not like that ought to be able to be solved with automatic builds and installations. Yeah. Does that answer your question?
Yep.
Yeah. Okay. Yep.
So I'm assuming that you're having enormous path strings to support this. Is that
Yep.
true?
Yeah. So by default, yes. And so that was that. Did you? So okay. Sorry. The question was you have enormous path strings and your environment can blow out, especially because these paths are quite long. And there was the comment made earlier as well that isn't there a limit to the size of the environment? And the answer to that is yes, there is as well. So that is an issue, that can be a problem. It's also a problem for performance reasons because if you've got 1,000 entries in your path, that's going to take a while to search every time you try to run a program. The solution is to adopt a sort of hybrid between Symlinks and the environment. And so the idea is to have a sort of a meta package, which is a collection of Symlinks back into your typical canonical collection of packages that you use most of the time. And this is very similar to the approach taken by all the rest, like Stow and Gobo Linux and Nixos. And that then you would have that one package loaded most of the time, and then when you want to have exceptions from that, you can then load them on top of that package. I'm about halfway through implementing that. You're right, this is a major sticking point for actually having a working system all the time. In practice, we've used such a sort of setup in a earlier incantation on the supercomputers that we run at NCI, and it works reasonably well. And that's on shared Lustre file systems as well. So they're a lot slower than local disk, and it's still bearable. And what was I going to say? There are various subtleties and nuances in doing this. It's a little more complicated than just having a tree of Symlinks, because you need to keep track of which real packages the meta package is actually giving you access to, and then if you load something on top of that, you need to keep track of dependencies properly, and there's a curly issue around whiting out of files, which is really, thankfully doesn't actually happen very much. So the problem here is suppose that your meta package had a particular version of a piece of software and that provided access to a program called foo, and then you loaded a new version of the package on top of your meta package, which puts it earlier in the path, which is fine, except this other version now, the specific version, doesn't have program foo anymore. So what should happen is when you type foo, you should get command not found. What actually happens is you'll get the foo from the earlier version, from the meta package. And that can cause confusion. But that's this is an advanced subtlety that I'm getting around to now. Any other questions before I move on to next? Yeah.
What's the problem with the lots of symlinks approach?
So the question is, what's the problem with the lots of symlinks approach? For myself, the main problem is actually the inflexibility. So you either have symlinks being system-wide and affecting all users and all processes, which on a multi-user system has obvious problems. But even on a single-user system, I find it can be very useful to sometimes have different processes looking at different package versions. And so the alternative to that with still using symlinks is the approach that Nixos takes, where you have sort of multiple of these meta packages, all with different sets of symlinks. The problem with that then is it tends to not scale. You end up having a lot of symlinks, and so like running out of inodes is a major problem then. Just come back. So for example, a lot of these packages that I'm using here are actually Nix packages installed in Nixos and then pulled out and then basically string substitution to change the Nix paths into Syzix style paths, which actually works reasonably well even over binary files. And so and when I was doing the Nix install for this, doing it naively on a 100 gig disk, even ext4 1K inodes, and it ran out of inodes about halfway through, after about 25 gigs of actual usage, and there's 50 gigs of software or something. So scaling is a problem. So the other problem that, I'll come back to, so maybe I should just go ahead. Does that answer your question?
Yeah, that's fine.
Okay, any other questions at this point? Okay. Okay, so I've sort of already started on this a little, I guess, so I guess it's opportune. So to compare Syzix to some of the existing systems, and how are we doing for time? Yep. So Stow is the original one. It's very symlink heavy. Stuff gets installed usually under user local, and then Stow really is a system for managing all of those symlinks, which usually live in places like user local bin. So this doesn't get you any runtime switching, and that's largely what I want. For Python, virtual env, RVM, and what was the Perl one called? Perl Brew, right. So these are all good, except they're domain specific. They sort of work for their language. They work reasonably nicely. And RVM...
Daniel Bernstein one as well.
There's Perl local, but does that do multiple versions? I'm not sure.
No, but Daniel Bernstein has a generic tool similar to this that's not domain specific.
Right, okay.
But then you have to live in his world.
Yeah. Okay. So OS Tree is a recent one. It's very focused on binary packages and this idea of entire trees of operating system installs, so cheroots basically. And it seems to need reboots as far as I can tell for switching between things. And also no scalable way of composing different bits of different trees. That, much like what I mentioned with Nixos before, if you want to take a tree and just change one version of one package, you've kind of got to build a whole new tree which is the same but just a little bit different. Gobo Linux is quite good, but it's also symlink heavy, and there's sort of runtimes. I mean, there are symlinks that you can twiddle, but it's not runtime switching the way I would like it using the environment. And I can't handle Gobo Linux the way that they have completely abandoned FHS. And I mean, I can't type capital system, capital configuration instead of / etc. Right? So anyway. And so then there's NixOS, which is one of the closest, probably the closest thing to Syzix. So Nix is a purely functional package manager, which means that package installs and package builds have no side effects and are fully specified at build time. And I got these slides the wrong way around. So Yeah, so builds are fully specified at build time, and so this is very good. It gets you a lot of very nice properties. It gets you atomic upgrades. It gets you guarantees in terms of reliability, consistency, rollbacks, and that sort of stuff. And you can also do, I think they've got a daemon which will nicely handle unprivileged package installs as well. So in this case, everything goes into /nix/store. And the way that they achieve, the way that they enforce the pure functionality is they take a SHA-1 hash over all of the build inputs. So that's the entire source code and all of the previous, all of the build dependencies. And by doing this, they more or less get down to bit reproducibility of builds and of software products. So you can be absolutely 100% sure, more or less, that if you run this bash on any Nix system, or if you copy this and its entire closure of dependencies onto some other system, it will run the same everywhere. There are issues though. So my primary problem is that dependencies of build time, and this makes runtime switching tricky and difficult. It also, so the full sibling trees that I mentioned before. Rollback tends to be system-wide, not per package. Again, this is this issue of full sibling trees to define an entire profile, they call it, which is kind of like an environment. The hashes are completely opaque, and I find it awkward and clumsy that they're at the start and not after the version. It makes tabbing around in the shell really difficult. And this is kind of a cosmetic thing, but it seems fairly hard-coded in this Nix source from what I can see. And also having a flat directory structure, so they store more than just package install directories in the Nix store. Everything goes in there. Build input files, downloaded tarballs of source that they're going to build, everything. And this, I find, scales not terribly well. And on a shared file system, it definitely won't scale well at all. But it also means that if you want to change a fundamental library, then you've got to rebuild that library, and all of the things that depend on it need to be rebuilt from source. So if you want to change even just one character in glibc, you have to rebuild the whole system, doubling your disk usage space, taking forever. And they have binary caches to help with that sort of thing. And because everything's hashed, you know that you're getting the exact right version that you're after, and that helps. But it does mean that applying security patches can be a problem. It scales badly with disk space and inodes, as I mentioned. And as I say, if I want to change a bit of glibc, I just want to rebuild glibc and then swap that into whatever I happen to be testing it with, which may be itself or whatever. And so then this bit reproducibility, so they use the entire source to get the hash, where in some cases it might be better to just use the interface that a particular package presents externally. So maybe just the glibc header files, for example. That would slightly weaken Nix's guarantees, but I think in a useful kind of way. They mount Nix store read-only, and that's fine because everything's immutable. And in Syzix, the intention is that things should mostly be immutable. If you wanted to change something, you probably should just be copying it to a new version and sticking -2 on the end or something more descriptive than -2, because the hashes are not particularly descriptive either. And then working in that version, because you can easily switch to it after all. And they timestamp everything to 0, so it looks like everything I've installed is in 1970. Which, again, they're aiming for reproducibility, and if you tar these things up, then people building at different times might have slightly different tarballs. Anyway. Okay, and then there's GUIX, which is actually how I found out about NixOS. This was announced a few months ago. And it seems to me to be basically the same as Nix, but using Guile instead of Nix's specific custom functional language. And so therefore I can't really see the point very much. And I'm pretty much out of time, I think. So are there any final questions on this? Yep.
I guess the package management part of things, how do you know that a bit of software after 5 years, a bit of software now its dependency tree is no longer used? How do you remove all of those traces of those old versions?
Yep, okay, so the question was on a package management side of things, how do you know, given a particular piece of software after some length of time, like 5 years, how do you know that it and all of its dependencies aren't used and then get rid of it? So the answer is in Syzix at the moment it's manual. There's no way, but it's that's the sort of thing where I think simple tools like even just shell scripts maybe would be able to sort that out, because you can ask Syzix packages for their dependencies and figure this sort of stuff out. Nix has formal garbage collection, the way you would expect a functional based sort of thing to work. And Syzix may need a similar sort of thing to sort that out. And in terms of, so for example, at the moment, to remove a package off disk, it's rm-rf, right? So, does that answer your question? Yeah. So any other questions? I'm out of time. One last one. Yep.
Would there be any complications in running a hosted Syzix install in a per user setting, so installing the .sw and home directories?
So the question is, are there issues and complications with running a hosted install out of, say, a home directory? The answer is not really, and there is support for that in there. The main catch is you've pretty much got to build everything yourself from source, because too much software hard codes where it's installed inside it, and so the problem then becomes that if you've hard coded /sw blah 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 and you actually make use of that, you can't just take that and stick it in home and expect it to work. But if you build everything from source, which the tricky part of that is getting your toolchain right in the first instance, then build everything off the top of that, then it should be possible. Yeah. Okay. And so any other questions, then feel free to catch me offline. I'll be around all week. Thanks very much.